we talked about solving these systems of equations word problems, and there were 4 basic steps to make that happen. And those steps were, step number 1, let's put this back up here. You need to define your 2 variables. Those are usually x and y. And the last part of every single one of these problems is where you would figure out where what your variables are going to be, what they will represent. So the first 3 problems we did, we defined our variables as 2 different numbers. And then the 2 that we did after that, from the second page of notes, on number 7, we were figuring out the cost of a box of envelopes and a cost of a box of paper. So that's what those variables represented on that one. And then the very last one, we were trying to figure out how many of each type of lawnmower was sold. So we had small lawnmowers and large lawnmowers, the number of them sold. So every single one of these problems will tell you what things you are trying to figure out. Those will be your 2 variables every single time. So starting off here, we're going to go ahead and take a look at, let's see, between 12, 13, and 14, we're just going to, and 15, we'll do one of those. Let's say, just taking a look here, making sure that everything looking good. Let's go with number 13. So we'll look at number 13. 13 says that a group of 40 children attended a baseball game on a field trip. Each child received either a hot dog or a bag of popcorn. Hot dogs were $2.25 and popcorn was $1.75. If the total bill was $83.50, how many hot dogs and bags of popcorn were purchased? So we're trying to figure out how many hot dogs were purchased, how many bags of popcorn were purchased. So setting this up with x and y, our 2 variables are going to be, x is going to be the number of hot dogs. So number of hot dogs. That's what we're trying to figure out. It's one of the things we're trying to figure out. The other thing we're trying to figure out, number of popcorn. So how many bags of popcorn were sold? So number of popcorn. So again, every single time you're working on these problems, I would expect you to, at the very least at this point, be able to set up and define what your variables are going to be. Every problem tells you exactly what you are trying to find. So those 2 things will always be x and y. All right. Once we have our 2 variables defined, we need to write our system of equations. So we have to write 2 equations. And that's where this is going to be. This one's going to be maybe a little bit more challenging than some of the other ones because there's a lot of information just kind of spread out. And yesterday on our I think the very last problem that we looked at yesterday, the very last problem that we looked at yesterday, we had an equation where we used the total amount of things that were sold, 30, and we added those x and y variables together to get 30 because we were looking for the number of something. So if you have a system of equations and you've defined your variables as the number of something, number of mowers, or number of hot dogs sold, number of popcorn sold. If you're trying to figure out the number of something, chances are you're going to end up with an equation that is x plus y equals, and then the total number of things that were sold. So let's think about this for a second. Do you see anywhere on here where we could say the number of hot dogs plus the number of bags of popcorn equals the total number of something? And that total number of something might not tell you how many items were sold, but there is a clue at the beginning of this problem as to how many things were actually sold because it tells you how many people went to the game. So how many people went to the game? What was it? So yeah, the number of people, 40 people. And so the 40 children who went, every single one of those kids says each person received either a hot dog or a bag of popcorn. So that means that between those 2 things, 40 of those in total were sold. So our first equation here will be x plus y equals 40. Because every kid got something. We don't know how many of each, that's what we're trying to figure out, but we know that the total amount of hot dogs plus the total amount of popcorn adds up to 40 because every kid got one of those 2. The other equation is going to have to do with the amount of money that was spent. And so we know how much a hot dog costs, $2.25. We know how much a bag of popcorn costs, $1.75. And we know how much the total bill was, $83.50. And so this one's going to be a lot like that second equation from our number 11 yesterday, where we said the cost per the small mower right here, $249.99 times the number of mowers, X, plus the cost of a large mower, $329.99 times the number of large mowers, Y, equals the total amount that was sold, which was $8,379.70. So it's going to be the same idea on this problem here. We're going to take the cost of a hot dog, $2.25, multiply by the number of hot dogs sold, X, and then we're going to add that to the cost of a bag of popcorn, $1.75, times the number of bags of popcorn sold, Y, which we don't know yet. And that equals the total bill, which was $83.50. So our second equation is right there. 2.25x plus 1.75y equals 83.50. All right. So step one, we've defined our variables. Step two, we have our system written. Now, step three, we need to go ahead and solve this. So we're going to use either substitution or elimination in order to solve this. And each of those will take about the same amount of work and the same amount of space on your paper. So what method would you prefer to choose? Whoever says it first will use that method. So what do we want? Substitution or elimination? First person to say it, that's what method we're using. Elimination. All right, let's do it. So elimination. And the nice thing about using elimination here is that our X's and our Y's and our equal sign and our numbers are all in the same order. So that means that they're lined up. So that means we've got a 1 with our X and our Y up top. So in order to get elimination working here, we have to multiply just the top equation because these are 1s, which makes the multiplication a little bit simpler. So now we have to decide, do we want to eliminate the X's or the Y's? So which one, X's or Y's? X. All right, let's eliminate the X's. So if we eliminate the X's, we have to multiply the top equation to get the opposite value in front of X as the second equation. So the second equation is 2.25. So on the top, we're going to need negative 2.25. So what do we have to multiply the top equation by in order to get a negative 2.25 in front of X? What do you multiply 1 by in order to get it to equal negative 2.25? Yeah, negative 2.25. So we're going to multiply just by negative 2.25. That's the nice thing about when your number with the variable is 1, you can just multiply it by the opposite of whatever number you're trying to eliminate. So now we have to rewrite both equations. The first one's going to change, the second one will not. So the first equation, negative 2.25 times 1x is negative 2.25x. And then we multiply that by y as well. So that'll be minus 2.25y. And this is where your calculator will come in handy. Negative 2.25 times 40. That's why I was having, hopefully, not everybody got one, but having a calculator in front of you will make this a lot easier. Negative 2.25 times 40. Anybody have it? I'll wait until somebody gets that typed in. Negative 90. All right, so negative 90. So our first equation we've multiplied and we're good to go up there. The second equation stays the same, 2.25x plus 1.75y equals 83.50. Now we are ready to combine those two equations by adding them because we have opposite values with our x. So we're going to add those two equations together. And the positive 2.25x and the negative 2.25x, those will cancel out. And then we're going to add these two together here, negative 2.25 plus 1.75. And that is negative 0.5y. equals, and then negative 90 plus 83.50, which is negative 6.5. And this is another situation where when we solve, I just want to make this really clear again, the number of hot dogs and the number of bags of popcorn, those have to be positive whole numbers. There's no other option. You can't go to a baseball game and buy half of a hot dog or a third of a bag of popcorn. They're not going to do that. Have I ever tried? I mean, you could cut a hot dog in half, but you can't buy just half a hot dog. So no, because then you'd be giving a hot dog to them, which really doesn't make sense. I mean, you could. I don't know if they would take it though. So we got to have positive numbers. We have to have whole numbers when we're dealing with our X and our Y values on this particular problem, because those are the only types of numbers that really make sense in terms of selling hot dogs and selling popcorn. So we're going to take our negative 6.5. We're going to divide both sides by negative 0.5. And I think that ends up equaling positive 13, but I'm going to double check just to make sure. Yeah, equals 13. So Y equals 13. Positive whole number. That's good. So then, once we have our Y value, we can then plug this back into one of our first original equations, which I'd say plug it into the first one. So we're going to have X, space under here, X plus the value of Y, which is 13, equals 40. And then so to get X by itself, we'll just subtract 13 from both sides, minus 13, which means X equals 27. Another positive whole number. So that means 27 hot dogs and 13 popcorn. And that's our answer for number 13. All right, so that's the only one of those 12, 13, 14, and 15 we're going to do there. What we are going to do next is we will take a look at some of these coin problems. And let's just go ahead and hop to the second page here. And we're going to do a few of these actually. So starting with number 17. Starting with number 17. We're going to do 17 and 18 just because when we're talking about values of coins, I want to make sure that we have that written down. So we'll do both of these problems. And let's go ahead and do this quickly. I'm going to be pretty quick with these two. So here we go. Mary has a collection of nickels and quarters for a total value of $4.90. If she has 42 coins total, how many of each kind are there? So we need to know how many of each kind of coin she has. The first one here is nickels. So X is going to be number of nickels. And then Y is going to be number of quarters, nickels and quarters, number of quarters, not dimes. Dimes are on the next problem. So we've got nickels, we've got quarters. Again, this is a situation where you're trying to find the number of each type of something. So if it gives you a total number of things that there are, you can do the X plus Y equals total number of things. And since there are 42 coins total, the number of nickels plus the number of quarters equals 42 coins. So our first equation will be X plus Y equals 42. That's our equation for total number of things. Now, the next one we have to write an equation for the total value. And the total value is $4.90, but that's the only number we have for our total value. What other information do we need to use? We saw a question like this a few weeks ago with our other word problems that we did with linear equations. And so when you have coins, what do you have to include on your own? Anybody remember? What's that? So if we know how much money there is total, we also need to include the value of a nickel and the value of a quarter. And we have to do this in terms of dollars because that's what we're dealing with here is dollars. And so how much is a nickel worth? 5 cents, right? But 5 cents is in terms of cents. We need this in terms of dollars. So a nickel is going to be 0.05. So I'm just going to put that right there, 0.05, because that is the number we're going to use in order to write our second equation with that $4.90. And a quarter, what's a quarter worth? 25 cents, which would be 0.25 in terms of dollars. So now that we have our values, which you have to have when you're talking about coins, now that we have our values, we can write our second equation. And our second equation will look really similar to the second equation we wrote on the last problem. You have the value of a nickel, 0.05, times the number of nickels, x, plus the value of a quarter, 0.25, times the number of quarters, y, and that equals the total amount of money, which is $4.90. And so this system looks pretty much just like the one we did on the previous problem. And so I'm going to say, let's just go ahead and use elimination again. Let's go ahead and eliminate the x value again, which means we're going to multiply the top equation by the opposite of the value of x down here. So we're going to multiply everything on the top equation by negative 0.05. And that will give us opposite values in front of that. So once this is written, the two equations, or the two problems that we just did, they're going to work pretty much exactly the same. And so if everything on the top equation gets multiplied by negative 0.05, we get negative 0.05x minus 0.05y equals, let's see, 42 times 0.05, or negative, sorry, 42 times negative 0.05 is negative 2.1. And the bottom equation stays exactly the same, negative 0.05x plus 0.25y equals 4.90. Now everything's nice and lined up. Sorry, that was a positive 0.5x down there. And then we're going to add the two equations together. So 0.05x plus 0.25y equals 4.90. And if we add a negative 0.05 to a positive 0.05, those cancel out, so the x's are gone. If we add these two numbers together, negative 0.05 plus 0.25, that's 0.20. And then the last one here, negative 2.1 plus 4.90 is 2.8. So we add together the two equations, and then we're going to divide both sides by 0.20 on both sides. And this should give us another positive whole number because we're trying to figure out how many nickels and how many dimes there are. And those are going to be, you either have 1 nickel or 2 or 3 or 4. You don't have half of a quarter or anything like that. So this is going to end up being, let's see, 2.8 times, or not times, divided by 0.2, and it ends up being a whole number. It's 14. So y equals 14. So if y equals 14, we're going to use our very original first equation here. So we'll have x plus the value of y, which is 14, equals 42. And then we'll subtract 14 from both sides, minus 14, minus 14. And x equals 28. So what this tells us is that Mary had 28 nickels and 14 quarters. So 28 nickels, 14 quarters. That's our answer there for number 17. All right. We're also going to do number 18. It's a very similar question, but instead of nickels and quarters, it's nickels and dimes. And just to make sure that we have these examples here with the values of these coins, it's good to do this one as well. So 18, Rob has $1.65 in nickels and dimes. So between the two, he has $1.65. He has 25 coins in all. How many of each kind of coin are there? So again, we're starting with nickels on this one. So X will be number of nickels. And Y will be number of dimes this time. So we've got dimes instead of nickel or quarters, dimes instead of quarters on this one. Nickels, we know 0.05. Dimes are worth 10 cents, so that's 0.10. We have the value of those there. It says he's got 25 coins. So the number of nickels plus the number of dimes equals 25 coins. So X plus Y equals 25. And then it says he has $1.65 with all those coins. So that'll be 0.05X plus 0.10Y equals 1.65. Again, this looks like the previous two problems that we did. Let's eliminate Y first this time. So I'm going to multiply everything by the opposite of 0.1, which is negative 0.1. So negative 0.10, multiplying everything on that top equation. So if we rewrite our equations, that'll give us negative 0.10x minus 0.10y equals, I think that's going to be negative 2.5. So times negative 0.1 is negative 2.5. So there's that first equation multiplied by negative 0.1. The bottom equation stays exactly the same, 0.05x plus 0.10y equals 1.65. Everything is lined up. We have opposite values in front of the y variables. So when we add these together, we're still going to have x. And negative 0.10 plus 0.05 is negative 0.05. So negative 0.05x. The y variables cancel out altogether. And negative 2.5 plus 1.65 is negative 0.85. To get x by itself, we'll divide both sides by negative 0.05. Means that x equals 17. Now that we have x equals 17, we can plug it into the very first equation and say x is 17, so 17 plus y equals 25. Subtract 17 from both sides. And y equals 8. So x is 17, so 17 nickels. 8 dimes. So y equals 8, so that's 8 dimes. There's our answer right there for number 18. All right, so you see some questions about coins on your assignment as well. And the last one we're going to do, we're going to do one more, and we'll do the very last one on here, number 20. So make sure you have 18 on there. We'll skip 19, we'll do 20, and that'll be it. All right. Last problem here, which again, these all set up very similarly to one another. I hope you're starting to see that a little bit. So number 20 says, Miss Miller decides to give a test worth 90 points and contains 25 questions. Multiple choice questions are worth 3 points and word problems are worth 4 points. How many of each type of question are there? So we're trying to figure out the number of each type of question. So what are the 2 types of questions on this test? Somebody tell me, what are the 2 types of questions? We're trying to figure out how many of each type of question there are. So what are the two types of questions? Anybody? What types of questions are on that test? Yeah, multiple choice is one type. Those are worth 3 points. Word problems is the other type, and those are worth 4 points. So number of, let's say multiple choice, and then number of word problems. So those are the two types of questions, word problems and multiple choice questions. Multiple choice is the one that was listed first, so we'll say that's X. Number of word problems, that's Y. Now, we also know that if you add together the number of multiple choice questions and the number of word problems, that tells you how many questions there are on the test. How many questions were on the test? Tells us in the first sentence, how many questions were on the test? 25 questions. Good. So the number of multiple choice questions plus the number of word problems equals the total number of questions, which is 25. So our first equation is going to be X plus Y equals 25. So once again, you can see we have an X plus Y equals equation as one of our two. A lot of these problems end up giving you an X plus Y equals something else. Now we need to write an equation that represents what? Anybody know? There's another thing on here that's being talked about. What is it? What is it? The points, yeah. So the test is worth 90 points, and we know how much a multiple choice question is worth. How many points is one multiple choice question worth? What does it tell us about that? 3 points, yeah. How many points are word problems worth? 4. So our other equation will be talking about the point values. So if we have 3-point questions, which would be multiple choice, so 3-point questions times the number of multiple choice questions, plus 4-point questions, word problems, times the number of word problems, equals the total number of points, 90. So our other equation, 3x plus 4y equals 90. All right, now the last thing we need to do here is end up solving this. And again, we could use substitution or elimination. We've been going with elimination, so let's keep going with that. And if we're going to use elimination, which equation should we multiply, first of all? First one or second one? First one, okay. And then do we want to eliminate x or y? X, okay, so what are we going to multiply the top equation by? Okay, we'll eliminate y then, so what do we want to multiply the top one by? Yeah, -4. So we'll multiply the top equation by -4. That'll give us opposite values in front of the y variables. So if everything on the top gets multiplied by -4, that'll be -4x minus 4y equals -4 times 25 would be -100. On the bottom, that second equation stays exactly the same. 3x plus 4y equals 90. All right. If we add together our two equations, because we have opposite values in front of y, a -4 plus 3 is -1. So that's -1x equals, because the -4y and +4y cancel out, -1x equals -90 plus, or -100 plus 90, which is -10. So then to get this by itself, we'll just divide both sides by -1, which means x equals +10. So x is 10. And then we can use the very first equation from back over here to figure out what y is equal to. So we'll plug in 10 for x. So we'll say 10 plus y equals 25. And then to get y by itself, we'll subtract 10 from both sides. And that means that y equals 15. So the number of each type of question would be 10 multiple choice, and 15 word problems. That's our answer for the last question. So we're going to stop it there with our notes. Everybody already has an assignment. So get that assignment back out in front of you. The one that we started on yesterday, we set up some problems. Keep in mind, if you were gone yesterday, we crossed off number 5 and we crossed off number 10 because they had a line through it and you can't really read them. So that means there's only 8 problems to do. 1, 2, 3, 4, 6, 7, 8, 9. We set up 3 of them yesterday. So the rest of the time is yours to do this, and that we have half of class. So we have 35 minutes. So keep working on this and let me know if you have any questions.